Good day everyone, this is the Cadet Apollo Leandro and we are the Group 1. Today we will discuss and tackle about ship handling and maneuvering. So this group composed of the Cadet Abadias Ralph Joel, the Cadet Apollo Leandro I myself, the Cadet Bicaldo Art Ryan, the Cadet Bilangigi Ramilo, the Cadet Busa Jeffrey, the Cadet Capalda Patrick, the Cadet Cabaluna Dave Justin, the Cadet Caminadi Shankrel, the Cadet Katubay Jacob, the Cadet Celestius Roy J, the Cadet Cunyado Steven, and the Cadet Kotara Albert. So the learning objective of this discussion is to first describe the different principles in ship handling, and second, explain the significance of deadweight, the draft, trim, speed, underkill clearance, turning circles, and stopping distance in ship handling. So, what is ship handling and maneuvering? It is defined as the art of proper control of a ship while underway, especially in harbors, around docks and piers. It is one of the skills that any ship handler finds very satisfying when well accomplished. The most basic thing to be understood in ship handling is to know and anticipate how a ship behaves under all circumstances and what orders should be given in order to make the ship behave and move exactly the way you want her to. So basically, ship handling and maneuvering, it is a skill that a captain or master must acquire or must know how the vessel he handles or how the vessels behaves or acts in maneuvering.
Good day, sir. This is Cadet Abadias, and what's the principle of ship handling? So these are the three basic ship motion. Number one is longitudinal motion, forward or astern, and number two is lateral motion, sideways, and rotational or turning motion. So vessel also have other behaviors worth noting with when her maneuvering equipment is in operation. Depending on the type of propeller, a ship with a single propeller when run ahead from stop cans to either pull to starboard. When to put astern from stop, the stern cans at a fast rate to pull to starboard. And the next one is principles of ship handling. So when a ship has headway and the rudder is put over to one side, the boat turns to the same side where the rudder is turned. So for example, you go to the starboard, so the boat turns to the same side where the rudder is turned, so it will go to starboard. That's for example. So thrusters, on the other hand, move the vessel sideways. So for example, if the bow have some thrusters and it turns on, so for example, it will go to it sideways to the port or to the starboard side, like that. And thrusters, depending on its design, increases its effectiveness as the vessel slows down.
Hi, I'm Martin Bicaldo. I'm going to report the principle of ship handling, factors and processes that commonly constitute a change in a vessel's behavior while being maneuvered. External factors versus tide, a sudden change in wind velocity and direction, gas, next sit and drift, the proximity of other vessels, the depth of harbors. Principle of ship handling, internal factors versus under the control of the ship handler. First, engine power, speed, effect of the type of propeller, rudder, movement and type, thrusters, anchors, and mooring lines, tugboats.
Hi everyone, this is Cadet Bilangigi, and I am here to discuss the principles of ship handling. Effects of external forces. The effects of external forces may become advantageous or disadvantageous to the ship handler. It is best that these effects are foreseen before so that necessary steps to counter or make use them during the maneuver are made. As some experts put it, the art of ship handling involves the effective use of forces under one's control to overcome the effects of external forces. Among the external forces, the effects of the wind and current are the most important. These forces greatly affect the movement of the ship. When there is a wind blowing on one side of a high-sided ship moving ahead, she will not move along the line of the intended course's line, but rather drift toward the lee side of the ship. Likewise, if a current is acting on one side of a ship, she will behave in the same manner. That is, she will be moving diagonally in the direction where the current is sitting, although her heading is on the course steered. To attain the desired track, we make allowances to compensate for a current and allowance for leeway to compensate for the wind.
Good day, everyone. This is the Cadet Busa Jeffrey, and I will represent the principles of ship handling, effects of external forces. Always bear in mind that current affects ships more than the wind and allowance, where the compensate for these factors are called set, because generally it is not possible to separate the different. If a ship steers a course of 270 degrees and the current is sitting north, she will be deviate considerably towards the north from the course line. The angular difference between the ship's heading and the course made goods is called the drift angle. In the next example of principles of handling, ship's handling, the set. Ship angle can be estimated graphically or by mathematically calculated. This drift angle is applied opposite to the set of the current in order that the ship will be progress along the intended course line. The factors affecting the drift angle depend on the world condition of the ship. The speed of the ship is the velocity of the wind or rate of the current and their direction relative to the ship's fore and after line. Then there is also the effect to ship's speed and the wind or current is ahead or astern.
Good day everyone, I am Dan Cadet Cabalda Patrick, and today I will be discussing these topics, which is the principle of ship handling, significance of dead weight in ship handling. So there are multiple variable factors affecting ship's handling, one being the human factor, a delay in time between your given order and the execution of the ship, or the order will affect how you intend to move your ship. Second, which is a sudden breakdown or failure of the ship's equipment. And third, being the mode of communication failure from the bridge to engine room or vice versa. Third, which is the language problems between nationalities. And lastly, the ship's momentum. So basically any other form of transportation, whether it will be a land transportation, a vehicle momentum will greatly affect the handling in terms of maneuverability, and the amount of time needed to completely stop the ship is also affected by the momentum. So second topic is the significance of dead weight in ship's handling. So dead weight is a term used to describe the total weight of all cargo, fuel, water, and provisions that a ship can carry. It is a crucial factor in ship handling because it affects the ship's stability, the draft, and trim. A ship with a high dead weight will require more power to move and may have a deeper draft, making it more difficult to maneuver in shallow waters. Additionally, if a ship is not properly loaded to maintain its balance, it may become unstable and which may result in capsizing, which is the worst case scenario. Therefore, it is important to accurately determine the ship's dead weight and to ensure that it is properly distributed to maintain the ship's stability and to allow safe handling during navigation.
Good day everyone, I am Deck Cadet Kapaluna Dave Justin, and I will talk about the significance of draft in ship handling. Draft is also known as the ship's draft. Is a crucial factor in ship handling as it determines the minimum water depth as a ship can safely navigate in. The draft of a ship is distance from the waterline to the lowest point on the ship's hull, and is influenced by factors such as the ship's weight, or what we call dead weight, shape of the hull, and the type of cargo being carried. A ship with a deeper draft will require more water to float, limiting its access to shallow waters and making it more difficult to maneuver. On the other hand, a ship with a shallow draft will have more flexibility in navigating shallow waters but will have less stability in rough sea conditions. Draft also affects ship stability, as a ship with a deeper draft will be more stable in rough seas but less maneuverable, while a ship with a shallower draft will be less stable in rough seas but more maneuverable. Therefore, in a ship handling, it is important to accurately determine the draft of the ship and to keep it with the limits set by report and navigation authorities. This will ensure that the ship can safely navigate in the intended waters and prevent it from running aground or damaging the ship or the environment.
So, I am Cadet Shankril Kamnade, and I am here to talk about the significance of trim in ship handling. What is the significance of trim in ship handling? Well, trim is a crucial factor in ship handling as it affects the stability, the maneuverability, and the speed of the vessel. It also refers to the balance of the vessel in the water and is determined by the distribution of weight on the ship, such as cargo, fuel, water, and provisions. A ship that is properly trimmed with weight evenly distributed along its length will have better stability and maneuverability. On the other hand, that is not properly shipped, or a ship that is not properly trimmed with weight concentrated at one end will be prone to rolling, pitching, yawing, which makes the vessel more prone or hardened to handle. Additionally, trim also affects ship speed. A ship that is trimmed properly will have less drag and will be more efficient in its propulsion, resulting in faster speeds and lower consumption in fuel. Therefore, in ship handling, it is important to ensure that the trim of the ship is properly maintained, with weight properly distributed along its length to maintain stability, maneuverability, and speed. Improper trim can result in reduced efficiency, increased fuel consumption, and greater risk of instability, and worst of all, accidents.
I'm Cadet Jacob Katubay. So today I will perform the slide 9. So principle of ship handling. So effects of external forces. So effects of external forces may become advantages or disadvantage to the ship handler. So many experts put it the art of the ship handling. So it involves the effective use of the forces under one's control to overcome the effects of external forces. So among the external forces, the effects of the wind and current are the most important. So these forces greatly affect the movement of the ship. So The external forces that affect ship handling include the wind, waves, current, tides, interaction between vessel, or shallow water affects the bank. The magnitude of the influence that these forces have. So slide 10. So principle of ship handling. So effects of external forces when there is wind blowing on one side of a high-sided ship moving ahead. So she will not move along the line of the intended course's line but rather drift towards the lee side of the ship. So likewise, it is acting of one side of the ship. She will behave in the same manner. So she will be moving diagonally in the direction where the current is sitting, although her heading is on the course steered. To attain the desired track, we make allowance to set the compensate for a current and allowance for lee. We compensate for the wind. So the current shapes ahead will reduce the ship's speed over ground, improve ship response to the rudder, and also give more time to access or correct developing situation. That also.
So, significance of underkeel clearance in ship handling. Underkeel clearance is the vertical distance between the ship's keel and the seabed or underwater obstructions. It is a crucial factor in ship handling as it determines the minimum depth of water that a ship can safely navigate in. And if a ship does not have sufficient underkeel clearance, it can run aground, causing damage to the ship, its cargo, and environment. And in addition, if the underkeel clearance is too small, it can increase the drag of the ship, reducing its speed and increasing its fuel consumption. 4. In ship handling, it is important to ensure that the ship has sufficient underkeel clearance at all times. So this requires accurate knowledge of the ship's draft, the water depth in the navigational channel, and any underwater obstructions. The ship's speed must also be managed to ensure that it does not approach shallow waters too quickly, and to allow sufficient time for the ship to react in case of any changes in water depth or underwater obstructions. And in conclusion, the underkeel clearance is a critical factor in ship's handling and must be closely monitored and managed to ensure safety and efficient navigation.
So, good evening, I'm Cadet Steven G. Cañada, and my topic is all about the significance of turning circle in ship handling. So, what is the significance of turning circle in ship handling? So, turning circle are a crucial factor in ship handling as they determine the minimum radius of turn that a ship can safely make. So, it also determines the turning circle are influenced by factors such as the ship's length, beam, draft, the speed, and the rudder angle. In ship handling, the ability of ship to make a tight turn is critical for safe navigation, especially in crowded waterways, narrow channel, or emergency situations. A ship with a smaller turning circle will be more maneuverable and easier to handle, while the ship with a larger turning circle will be less maneuverable and more difficult to handle. In addition, the turning circle will also affect the speed and fuel consumption. In the ship, that making a tight turn will experience increased drag and reduced speed, resulting in increased fuel consumption. So therefore, in a ship handling, it is more important to understand the ship in order to keep within a safe limit. It also requires accurate knowledge of the ship dimension, draft, speed, and rudder angle, as well as proper understanding of navigational condition. such as the water dip and the presence of any other obstruction.
Good day, sir. I'm the Cadet Kotar Alberts. So, today let's talk about the significance of stopping distance in ship's handling. So, stopping distance is the distance a ship travels from the moment its engine stops until it comes to a complete half. It is crucial factors in ship's handling as it determines the minimum distance required for a ship to stop in an emergency situation. So, in ship's handling, the ability of the ship to stop quickly and safely is critical for avoiding collisions, grounding, or other types of accidents. The stopping distance of a ship is influenced by factors such as its speed, length, and draft, and the type of propulsion system. So, so if a ship does not have sufficient stopping distance, it may not be able to stop in any time to avoid an accident. So this can result in serious damage to ships, its cargoes, and the environment. So therefore, in ship handling, it is important to understand the ship's stopping distance and ensure that it is within safe limits. So this requires accurate knowledge of the ship's dimensions, speed, and propulsion system, as well as the proper understanding of the navigational conditions, such as the water depth and the presence of any underwater obstructions. In conclusion, stopping distance is critical factor in ship's handling and must be monitored and managed to ensure the safe and efficient navigation. So that's all, sir. Thank you.